So we are going to start multi-threading and threads. So before moving to multi-thread, what we need to discuss is thread. Like what is a thread and what is the purpose of using multi-thread? Okay. So when we say thread is a we can say separate path of execution, or we can say or a sub process of a process. So I believe you guys know what is a process, or we can say a lightweight process. Anybody have any idea like what is a process? So all these you can see HP Pen Control, Microsoft Edge, all these are process, right? And if anybody on Windows 7, then you can find out the threads which are basically running inside a process. Okay, so if we say process, so we can say process is a running program. You all knows what program is. Program is a group of instruction or set of instruction which can perform a specific task when you run it, right? So process is basically nothing. It's a program which is in running state. Okay. Now in the process, let's say this is your process. Let me call it P1. So there can be number of threads, like we have thread T1, thread T2, thread T3. Okay, let me take this example with Word. So we have this Word software here. Okay, and if I say like I start writing, so you keep an eye on here, like 0 word you can see, right? As I'm doing some work, what is happening, this is getting update, right? And like there is any except no, there is any spelling mistake, then you can see it's getting highlighted at the same time. So there are a number of processes which are basically have some responsibility to accomplish, right? Like one thread is there which is counting word, one thread is there which is counting page numbers, like on which page we are, one thread is for spell checking, like who are the incorrect word we are writing, and underline them with red. So these are threads working together to accomplish a certain goal. Okay. So similarly, when we write a program in Java, we can build threads or sub process inside a process to accomplish a task. Like now the thing is like when we will be needing it, right? So and if we go more in lemon language, so we can say to achieve multitasking, we have a concept of threading or multi-threading here in Java. So what basically multitasking is, like you are reading a newspaper, at the same time you are taking your tea, right? And meanwhile you are talking to someone else who is sitting in front of you. So at the same time, what you are doing three tasks: sipping your tea, reading newspaper, and talking to someone like who is there. Okay, so this is basically called multitasking. Similarly in programming, if we say multitasking, so you can say we are running multiple apps over here, right? At the same time, I'm running Zoom call, whiteboard, Excel, sorry, Word document I'm writing. So all this kind of stuff is comes under multitasking. Like at the same time, you can do multiple things. So now let's move to this concept, which is multi-threading. We'll see what is the purpose of using this. Now, if I say I have to do some task, what is task is now? Let's say I don't have any task. Let me just name task 1, task 2, task 3, and task 4. Okay, this take 10 minutes, this takes, let's say, 15 minutes, this take 20 minutes, and this one take, let's say, 25 minutes. Okay, these are some tasks we have wrote in Java, and they takes, let's say, 10 minutes, 15 minutes, 20 minutes, or 25 minutes. So the first task will complete in 10 minutes, second will complete in 15 minutes, third will complete in 20 minutes, and the task fourth will complete in 25 minutes. And if we run these tasks in a sequence, so what will happen, we will have a total runtime, or the time which will be taken by these tasks would be equal to 70 minutes, isn't it? Guys, tell me.
Yes, Anuj.
Yes.
Yes.
Now, if there is no dependency between these tasks, so what we can do is we can run all these tasks together, or we can say in parallel, right? So what will happen, like when we will be running these all tasks in parallel, so at max we will complete all the tasks in 25 minutes, isn't it? Like we start executing all the tasks at the same time. So first one, let's say this is our 25-minute time frame, for example. So first one will complete somewhere here. Let's say this is 10, and this is, let's say, 15, this is, let's say, 25. Okay, so the task one basically completed over here, task two will complete over here, right? Or let's say we are doing this, the endpoint is 25, so 15, the task 2 will get complete here, this is, let's say, 20, and task 3 will complete in this duration, and task 4 will in this duration. So max time we will be taking is 25 minutes. Getting my point, guys?
Yes, Anuj.
Okay, so I think someday I was talking about, let's say there is a 1 GB file, and you want to read it file, and you want to create separate copies of this. Let's say in this file you have some records of data to these, basically what you want to do is you want to persist or save these records into your database. Okay, you have a database server, and you want to read these records and want to persist in in your database. So what you will be doing generally, you will keep reading this file one by one, and you will keep writing data over here. Okay. Second thing would be like, if we create multiple file from this file, let's say we have divided this into 3 files, so we will have 3 separate files. Now what we can do is we can create 3 threads, T1, T2, 3, which will be like reading this part, this will be reading this part, and this will be reading this part, and doing the stuff. Okay, so To achieve multitasking, basically, we can use multi-threading concept in Java. Getting the idea, like what is the need?
Yeah, yes, Anuj, but I have one doubt from that day. At the time of storage in the database, we need to combine those three files into one file, right?
No, no, no. Basically, there are records. We haven't talked about much for database. So database is like your register where you make entries of your data. Okay, so we can write three threads which will be writing to your database. It will read
So
some
in this
data from
case,
here, will write here. This one will read, it will write here. This one will read, right here.
so in the same file, they'll go to.
Database, in database we don't have concept of file, we have concept of table.
Yeah, in the case of
Same
files,
table.
how it will be?
So first you will split your file into three file basically,
Okay.
or whatever your logic is like. Basically, what you will be doing, you will divide your file into multiple file. Then you can decide like how many thread you want to create, and you will assign the task to each thread. Like this is my task, I want to perform. So you will delegate the task to the thread, and thread will do that task. Okay.
Okay, then it will be saved in the in the form of three files, right?
No, no, no. Let's say we haven't seen XML or JSON yet. Let's say this is our employee information. So when we talk about third party server, third party application integration, so we cannot like for example, in this application I have method m1, or m1 method I have. Let's say this is app 1, this is m2, and this is some app 2 here, right? What this m2 wants, it want to call this logic which we have written here in m1. So it cannot directly call it. So what comes into picture is API. Okay, like it might be REST, it might be SOAP, right? Or like if you have the data in other formats like XML, you have already you have that data, so you can just export that data into your system and start consuming. So generally when we take REST, the data travels into the form of JSON, and in SOAP generally we prefer XML. So for example, you have an employee. In this employee you have ID, value is 1. Similarly you have name. So this is how your record look like. And when you save in table, what you do, like you have an employee table over here. So you have ID, name. So you will read this data. Basically you will write here the name. Next we'll go here. So these are basically called row. So what you are doing, you are writing your data into tables, or basically we can say inserting row in your database. Let me see if I have some database in my system. Yeah, I think I have, but not really sure it's working or not. I think it's not working at my system right now. Anybody has about idea about the database? What database is? Just tell me, guys, if anybody has any idea.
It has records and
Yes, yes. Right now, it's not working my system. But if I show you, so your database would be a, we can say it would be a server. There you can insert data, you can maintain your records basically. Okay, let me make a query on this. Where is between alter introduction section select? So generally a table inside database looks like this. Okay, so let's say you have record in XML or in your text file, and you will read that record from there and will keep that data insert in database like this format. Okay, so don't think much about that, we'll talk about that later on. For now you can just assume there is a table where we are going to insert this data. So if we have like, just take small example, 100 records. So if we are going to process one by one, so let's say one record or one line take 1 second to process, so we need 100 second to process, right? But if we divide this task into, let's say, 5 different thread and we say you will be each thread 1 2 3 4 5 will be inserting 20 records. So this will be inserting 20, so maximum we can do this into 20 seconds, for example. Okay, let me know if you have any doubt.
Okay, Nish, that's clear.
All
So,
right, now we will discuss what basically a thread is. Sorry, that we have discussed what is a thread, lightweight process or a sub process in a program. How to create a thread, we have discussed like what is a thread and why we require it. So when you want to achieve multitasking in your program, so you can use that to save time or to make use of multitasking. Okay, so before moving to life cycle of a thread, let me just show you how to create a thread. Or even before moving to that, we'll see like every program in Java has a thread. Even it's simple hello. So I'm just going to create simple hello world program and we'll see like thread is there or not. And if thread is there, then what is the name of that thread, all this kind of stuff we will see. Okay, so I'm creating a class test and I'm writing a main method over here, and it's a just simple program which prints hello. Okay, now if you want to see the name of thread this program is have, you can do one thing. There is a class called thread. In this class we have a method called get, sorry, it's current thread. So what it will do, if we use this method, it will find out the current running thread in your program. Okay, and will give us a object of this thread. So it is basically current thread which is running. And from this thread object, what we can do is we can check its name, current thread dot get name. Okay, so basically it's main. You can see the thread name is main. So every program which have a main method, we can say have a thread which is known as main thread. Okay, also there is a concept of priority, like we can talk about that later, the priority thing. So for now we can just say every program, when we say main method, it has a thread in it. Yes or no? Now
Yes.
yes, now how to, yeah, good. Now how to create a thread? So to create a thread we have two ways. What are the two ways? So we can use how to create a thread. There are two ways. The first one is using Runnable, or we can say implementing Runnable. So Runnable is basically an interface that we can use to create a thread. Second thing is extending, or I'll say using thread class. This one is interface. So we have seen like what interface is, what a class, right? So there are these two ways we can use to create a thread. Now we'll see the first one. Let's say this is our first one and this is the second one. So what we will write when we want to make a thread using a runnable interface, we need to create a class. Then what we will be doing, like my thread, name of the class is my thread. It will implements runnable interface. Okay, now can you guys tell me, when we say implements, what needs to be done or what is mandatory for this class? Anybody?
It should implement the interface and method should be over.
Yes. So if we implement an interface, all these method from that interface must be implemented in the class. Okay. So how we will do that? There is a method called run in runnable interface. We need to override that method. So this is the signature of that method, void run, and whatever you are writing here will be treated as a thread or thread logic. Okay, so this is the way one we can use. Second thing is that we can use class my thread extends thread class, and we can run this method over here, public void run. and you will write your logic over here in this way. Okay, if we go to this thread class, this is itself implements runnable interface, right? But if you want to give some logic to your thread, then you must implement this. When we say extend threads, so the run method is available for this class. Even we are not going to override, but it will not do the functionality you are looking for. So if you want to do something, you need to explicitly write that code here in run. Otherwise, what will happen, like when you will be saying start my thread, run method from this class will be called. Getting my point? We'll see these scenarios, like I'll come to that one by one. So for now, you just tell me like this concept is clear to you or not. Implements runnable and extends thread.
Yeah, yeah, clear.
Okay. Now let's go back. Okay, before moving to code, let me discuss like what are the pros and cons with using runnable and thread. So when we say extend thread, now what will happen in this case? This class cannot extend more classes. Getting my point? Because in Java, a class can have only one parent as a class. Interface can be multiple, but as a class, there can be only one parent when we say extends. But when we say implements, so this class can have a class as a parent and runnable as another parent of it. Getting my point? Let's say
Yes.
we are saying class my thread extend some x class and implements runnable. That is valid. We can do that, but we cannot write like this: class my thread extend x comma runnable. Sorry, not x, my thread, or sorry, x would be there. Here I'm gonna use thread. So only one class can be the parent of a class. Interface can be any number of. So this is not valid basically. A class cannot extend to class. Okay. So when we say we are going to build thread using runnable interface, we'll get the benefit of multiple inheritance, we can say. But if we are going to use thread class, we will lose this feature of multiple inheritance, which is basically not supported by Java. Because when we say multiple inheritance, so generally what happens inside an interface is just a signature or method name. Rest of the thing we need to define inside our classes. You are getting my point, guys?
Yes.
Okay. Now let me just create these two thread and run it once, and we'll come back to this theory part again quickly. So we have a class called my thread. Oh, okay. I have to write it down. My thread
Wow.
extends thread. Okay. Sorry. Public void run, and let's say we are printing for, sorry, or just 0 to 10. Let me make it 1, and here I'm gonna say 1 to 10. System.out.println I. Okay, so this thread basically responsible for printing numbers between 1 to 10, or let me make it 100 once. Okay, now if we really want to make a thread and start it, so we need to write something else as well. How we will do that? We need to create object of this class, my thread mt is equals to new my thread. So from this point, what we can say is what is wrong here?
Equal.
Oh, sorry. Yeah. So empty is basically a thread. Empty is a newly created thread. Okay. Now we have to start this thread. How we can do that? Empty dot start. When we say empty dot start, what will happen? Eligible, or we can say ready. This thread is ready. Thread scheduler will come and can pick this thread for execution. So just after this, we are going to discuss life cycle of a thread, like how it works. I'm just saying, run this. You can see we are getting number 1 to 100 printed over here. And one more thing, interested thing, we haven't called run method anytime. Are we calling this anywhere? No, we are not calling this, but it's running. Getting my point? So this is the beauty of thread. We'll discuss how it's working. Now let's say I have one more thread, that is, let's say M2 in this case. So right now, how many thread we have? Basically the main thread and the thread 1 and thread 2, and I'm saying start. So this time you will see the output some similar, like 1 to 100, and then again 1 to 100, but it's not the correct answer. Like we cannot predict it. Let me run it one more time. Even this time it is I've shared my entire screen, so guys, let me know if in case that is not visible, right? Now you can see like 100 and it's 16 here. So like yeah, 1 to 15 printed by one thread, then thread 2 got a chance to run, and it prints like from 1 to 1 to 19, and sorry, 100. Then the thread again got a chance to run, and here we go. So you can see the output we are expecting, like 1 to 100, 1 to 100 in sequence is not there, because there is no guarantee when there are threads. So you cannot guarantee that your output will look like this. So we will figure it out, like when we can make guarantee, when we cannot. So if you are like doing something this, then there is no guarantee. One more thing I'm going to describe, which is basically the thread you have seen, like main thread already is there, and if I say here, we need to do similar thing over here in this method. So this will tell us like which thread is running this run method basically. So here you can see thread 0, right? Like thread 0 is working. Now we got thread 1. So whenever we say thread dot current thread, and then current thread dot get name, we will get the current executing thread. So in this program, we can say there are 3 threads, and if you say uh, so by default, you can see the name we got is thread 0 and thread 1. Thread under thread dash 1, and there was one more thread 0, right? But if you want to set name on your thread, you can do something like this: empty dot set name. Name of your thread is, let me take T1. This is how you can set the name of thread. And similar thing I am doing here, mt2 dot set name, and I'm saying T2. Okay, and if I run this again, you will get the name when, even if I write this inside the println inside the loop, then it will be look better. Like, we will get to know which thread is working basically, T1 or T2. All right, guys. So let me print this here. Oh, sorry, I deleted wrong line. And if I run it again, so you can see T1, T2, T2, T1, T2. So this is how it's working. Like, sometimes T1 is getting a chance to run and executing their stuff. Sometimes T2 is getting a chance and executing their stuff. Okay, you cannot predict it like that. Here T1, 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 then T2, T2, T1, T1, T1. So you can see, like, T1 get a long chance to run, then T2 came, get a chance to run. So this is how, like, third thread works. We'll see more things like priority, yield, join. There are a number of things that we will discuss to make sure what we are going to achieve. Okay, so I believe you got the basic idea, like what thread is, what is the purpose of using, and how we can do that, like how we can make a thread.
Yeah, yes, Anuj.
Okay, now we'll discuss the thread life cycle. Okay, now this is a thread. When we say, let me just make it a bit more big. When we say my thread empty equals to new thread, that time the thread was new, or we can say born state. The thread is just born. Okay, when we say my thread empty equals to new my thread. Okay, now we can say the thread is in running state, sorry, new and born state. Then later on we did empty dot start. What it does basically, it makes the thread ready for execution. So this is basically ready state. When we say empty dot start, it's not right now running, it's ready. Like, server sorry, thread scheduler is a program running inside your operating system, which will come and see what are the different threads available in this program and what needs to be executed, right? So when thread scheduler picks a thread and start executing, the thread will go into running state, right? And once the run method complete, we can say thread is in run method completes, we can say the thread itself is in dead state, like thread is no more. Okay, but there might be a chance, like there are multiple threads, so we will be introducing a state called wait or waiting state, or is this one we can say like stop state. There would be one more state that is called waiting, and this will this one we will discuss tomorrow. Like there are multiple scenarios when a thread can come into waiting state from a running state, like when we say wait, or when we say, let's say, join, when we say yield, when we say sleep. So there are multiple scenarios like when a thread can come into wait state, and from this wait state, what will happen again when we will be like uh, starting it again, it will be in ready state again, like notify we are doing, or if we are using like yield, join, or sleep, let's say sleep we are using, so we can pass the time stamp here, like how many milliseconds we are going to sleep this one. And when this time expires, what will happen, this will wake up, the thread will wake up and will go and sit here into ready state, and again thread scheduler can come and start executing this. So this is basically the life cycle of a thread, like how it works. We'll have more clarity on this tomorrow. Everybody, I believe, has a clear idea what is a thread, how we can create a thread, what is the difference between using runnable and thread class, and a basic picture, like if you want to make a thread, how you can do that.
Yeah, yes, Sanju, we got a basic idea.
Okay, so and agenda for today was just to introduce with threads, how to create a thread, how to set name of a thread, what is the life cycle of a thread. Tomorrow we will discuss more in detail, like how to use sleep, yield, join, wait methods to make sure your program is in your control. Like the example we have seen, there is no guarantee of the output. Getting my point? So tomorrow we will discuss this stuff.